So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir and in today's lecture we are going to see how to solve a problem in which we have to check in an array whether a pair exists or not. Okay. So but before that let me say one thing that we have started a series of solving the DSA problems. If you haven't watched it yet or access them, I highly recommend to visit the playlist. The link is in the description box. This series is very important for those who are preparing for the placement and the interviews. If you know the fundamentals of the DSA or and getting stuck while solving the problems on DSA, then this series is for you. So again, the link is in the description box. Now let's come back to our problem. Now here we have to check in an array whether the pair exists or not. What I'm trying to say that let's say this is an array. Okay, now they have given us the value of k, which is actually the sum. We have to check whether a of I plus a of j is equals to k. Okay, in which I should not be equals to j. Okay, now here in this case the value of k is 7, so we have to see two elements in which the sum should be 7. Now we can see that if we take 5 and 2, the sum will be 7, right? So here in this case, the pair exists. Let's take one more example. The value of k is 9. Now there are multiple pairs here, but we have to just return the true if the pair exists or not, even if it is 1. Now 2 and 7, right? So 2 plus 7 will be 9. 1 and 8 also 9. 5 and 4 is also 9. 3 6 is also 9, right? So here there are multiple pairs, so we will be returning true here. Now there are multiple approaches for solving this question. The first approach should always be the brute force approach. Now here what we will do, we will be fixing our I and then we will be iterating our j. Okay, so here we are actually checking each and every pair. So let me take this example: 1 4 5 3 and 2. So here we will be checking each and every pair: 1 4, then 1 5, 1 3, 1 2, right? Then again 4 5, 4 3, 4 2, then 4 5 3, 5 2, and at last 3 2. So in any case, if the sum is equals to k, then we will be returning true here, right? So I will be starting from 0. Now you have to tell me from where the j should start. J should be starting from I, or it should be starting from I plus 1. So write your answers on a comment box. Now we can see that if the condition is that I should be not equals to j, right? So I so the j will be starting from I plus 1, right here. Now so the for loop will look like this. For I will be running from 0 and it should be stop till n minus 1. Why? Because let's say if I is standing here, then the j should be pointing at index 5, right? But we can see that no element is present at index 5, so it will give a null exception, right? So j should be stopped in this place. Okay, I plus plus. Now we know that the j will be starting from I plus 1 and it will go till n in every case. Now here if a of I is equals to a of j, sorry, a of I is plus a of j is equals to k, simply written true. That's it. Now in Now if the first for loop is getting over, okay, and yet we didn't find any pair, then we will simply return false. Let's dry run this code. I will be starting from 0 and J will be starting from 1. Okay, now we know that the value of K is 7. Okay, so 1 plus 4 is 5, which is not equals to 7. So increment J. 1 plus 5 is equals to 6, which is not equals to 7. 1 plus 3 is equals to 4, which is not equals to 7. So increment dj. 1 plus 2 is equals to 3, which is not equals to 7, right? So now I will be incrementing. Now j will be starting from 2. Now 4 plus 5 is equals to 9, which is not equals to 7. So increment dj. 4 plus 3 is equals to 7, right? 4 plus 3 is equals to 7. So we will simply return true. This condition is getting true, so we will return true. Now let's take one example in which the k is, let's take 15. Okay, so here we have to return the false. Now let's start from the top. I will be starting from here and j will be starting from here. 1 plus 4 is equals to 5, which is not equals to 15. So increment dj. 1 plus 5 is equals to 6, which is not equals to 15. Increment dj. 1 plus 3 is equals to 4, which is not equals to 15. Increment dj. 1 plus 2 is equals to 3, which is not equals to 15, right? So at this point, the for loop, the inner for loop is over, so we have to increment our I. Now 4 and the j will be here. J will be starting from index 2. So 4 plus 5 is equals to 9, which is not equals to 15. Increment dj. 4 plus 3 is equals to 7, which is not equals to 15. Therefore increment dj. 4 plus 2 is equals to 6, which is not equals to 15, right? So at this point, j, the inner loop is over, so we have to increment the I, right? So till this point we haven't gone inside this if case, right? So j will be starting from here now. So 5 plus 3 is equals to 8, which is not equals to 15. Increment to j. 5 plus 2 is equals to 7, which is not equals to 15. So inner loop is over. Increment the I. 3 plus 2 is equals to 5, which is not equals to 15, right? That's it. For loop is over. Both the for loops are over, and still we haven't gone inside this if case, right? So at last we will return false. Okay, so this will be the approach one. Now if we see the time complexity of this algorithm is actually order of n square. How? It is not actually order of n square, it is actually n into n plus 1 by 2. How? See, when I is standing here, the j is running for 4 times, right? When I is standing here, the j is running for 3 times, right? When I is standing here, the j is running for 2 times. So we can see that if the length is 5, for the first time, the j is running for 4, then 3, then 2, then 1. So we can see that it is a summation series. So due to that, it will be n into n plus 1 by 2. Okay. So if we solve this, it will be n square plus n by 2. So we have to take the dominant term, which is n square. So due to that, it is order of n. We haven't take any space here. So space complexity will be order of 1. So till this point, the time complexity is n square. Now let's take a look at the approach 2. Now here, let's take the big example. Now to solve this problem using approach to means we have to solve this problem in a more optimized manner. So we have to take the help of sorting, right? So first we have to sort this. Now if we sort this, the array will look like this, right? After sorting, the array will look like this. Now we have to take the help of two pointer technique. Okay, how? We have to place I here and j here. Now there will be two conditions. If a of I plus a of j is actually greater than, okay, greater than k, then we have to minimize our answer, right? So if you want to minimize our sum, then we have to do do j minus minus, right? So let's take one example here only. So I is standing at 1, I is standing at 0, and j is standing at the last index. So 1 plus 15, so it will be 16. Now 16 is actually greater than 9, right, which is k here. So we have to decrease, we have to minimize our result, that is sum. So what we will do, I'll simply decrement our j. Now we can see that if we sum 1 plus 11, it will be 12. So previously it was 16, now it is 12. So we have decreased our sum, right? Similarly, if we have our sum, which is a of I plus a of j, okay, is lesser than k, it is lesser than k, then we have to increase our sum, right? Increase our sum. And how can we do it? By incrementing our I, right? Now there is one more condition. If a of I plus a of j is equals to k, then we will simply return true. Okay, so this will be the three conditions. Now let's see using this whether we are able to solve our problem or not in a more optimized manner than the previous one. I will be standing, let me give the indexes. I will be standing here and j will be standing at the ninth position. Now 1 plus 15 is equals to 16, right? Which is actually greater than 9. So if the sum is greater than 9, then we have to decrement our j, right? So we decremented it. Now 1 plus 11, which is equals to 12, right? Now also 12 is actually greater than 9. So again, decrement the j. 1 plus 8 is equals to 9, which is equals to k, right? So we will simply return 2. So in this way we can able to solve our problem. So if we see in the worst case, I will be incrementing it and the j will be decrementing it, right? So I will be standing here and j will be standing here. Now we don't want that I should be go beyond j, and we don't want j should go beyond I. Okay, so we will be having a while loop because it will be a repetitive, right? Because let's say I is standing here, let's say I is standing here and j is standing here. So again we are comparing 7, again we are having the sum of 4 and 7, which is repetitive. We already done that, right? So while I should be lesser than j. So this should be the condition. Okay. Now the code will look like this. First of all, sort an array. Then we will have the while loop. I should be lesser than j. Okay. So you can initialize the position of I and j, in which I should be at the start and the j should be pointing at the last position. If a of I plus a of j is greater than k, right? So at this time we have to decrement our j. Why? Because we want to minimize our answer. Else if a of I plus a of j is lesser than k. Here, if a of I and a of j, the sum of them of both is lesser than k, then we have to increase our answer. And how can we do that? By incrementing our I. Okay. And else return true. This means that the sum is equals to k. Okay. And if the I and j goes beyond that, then we will return, the condition will be false and we will return false. Okay. So if you see the time complexity, this while loop will take order of n time. Sorting, if we take the help of the merge sort or a quick sort, it will take order of n log n. Okay. So if you don't know how to sort an array, I have made a playlist on in algorithms, right? The merge sort, all the sorting algorithms, you can have a look. The link will be in the description box. So it will be n log n plus n. So here we can see that the dominant term is this. So the time complexity will be order of n log n for solving the problem. What about space complexity? The space complexity will be order of 1 because we didn't take any extra help. But yes, if you're sorting this using the merge sort, then it will be, you will be taking the extra space, right? Now let's have a look on the third approach. So let's see whether we can optimize our time complexity from n log n to, let's say, order of n or not. So what we can do, let's take the array here also. The value of k is n, k is 9. Now if I say one thing, let's see, here the value of k is 9. If I take 2, let's say if I take 2, so 9 minus 2 will be 7. Now I have to just see or check whether 7 is present in an array or not. If it is, then we found our pair and I'll be returning true, right? So what I can do, I'll be using an hash set in which I'll be storing every elements, right? So 2, 7, let me create the hash set only. 2, then 7, 11, 15. You know that in a hash set, elements are stored randomly, right? So right now I have to iterate. Now I have stored the elements in the hash set. Now I have to iterate on an array. Now if I take 2, right? If I take 2, what I'll do, I'll just subtract the k from 2. So 9 minus 2 will be 7. I'll simply check whether this 7 is present in a hash set or not. Yes, it is. So I'll returning true. Okay, let's go forward. Now 7. Let's take 7. So 9 minus 7, which is 2. Again, it is present in an hash set. So return true. 9 minus 11. If you do that, then it will be -2. We can see that -2 is not present in an asset, so there is no pair of -2 and 11, right? Let's take another element, 15. So 9 minus 15 will be 6, sorry, -6. Again, -6 is not present, right? And this way we can do this, we can solve this problem. But there is one problem here. The problem is, let's say the value of k, is equals to 4, right? Now let's go one by one. Let's take 2. Now if we do 4 minus 2, the value is 2. Now we have to check whether the 2 is present in hash set or not. And yes, it is present, so we will be returning true. But actually it is false. Actually it shouldn't returning true, because the frequency of 2 is just 1. So according to this, what it is saying, that 2 plus 2 is equals to 4, right? So the frequency should be 2. The frequency of 2 should be 2, but actually we have the frequency of 2 is just 1, right? So if this is the case, then this using the hash set will not be the right answer for us. Okay, so due to this, we have to use the hash map. So here in the hash map, we will be putting the element as well as its frequency. Okay, so 2 frequency is 1, so I'm just putting the all the elements and its frequency. 7 1 11 1 15 1 8 1. Element 1 is also here, the frequency of 1 is also 1. 3 1 6 1 4 1 and then 5 1, right? So here what we will do, let's say the value of k is 9. Okay, sorry, the value of k is 4. Okay, now if we take this element, that is 2. Okay, actually I'm iterating over an array. Okay, so if we take the first element, which was 2, so 2. Now what I'll do, 4 minus 2, that will be 4. Now I'll check whether the 4 is present in an hash map or not, and yes, it is. But also I'll check what will be the frequency, because the array a of I and the element and the result we are getting is both are same. That is what I'm trying to see. If a of I is equals to k minus a of I, okay, if the result and the element both are same, then we have to check whether the frequency of k minus a of I is greater than 1 or not. If it is, then only we will return true. Otherwise, we will go forward. Okay, I hope I have cleared this doubt. Okay, so we have to use hash map here. Now let's see how we can do that. Now, first of all, I'll create an hash map using a for loop. Okay, so I'll just taking every element and just putting into the hash map. Then I'll be iterating over an array in which I will be running from 0 to n. Now in this, let's take the difference. The difference is k minus a of I. Okay, now we will check if the hash map contains the key, which is difference or not. Now here we have to check. If it is, then we have to again check whether the a of I and the difference are not same or not. If the difference is equals to a of I, then we have to again check, and it should be the frequency of I. HashMap dot get, it will get us the frequency is greater than 1 or not, then only return true. Okay, so in this way you can solve the problem using an hash map. So if you see that this for loop is actually running for order of n time, right? But we are taking the help of hash map, so the space complexity will be order of n. Okay, so due to this, it is quite efficient than the previous one, but we are using the hash map. Okay, so due to that, the space complexity will be the overhead now. Okay, now let's try to code this problem. So here we are going to practice that problem. Okay, so the topic is different, but it is actually the same. Here the topic is to sum, and we have seen check pair. So you can see that here we have the array and the target as 9. Okay, so if we sum up 2 and 7, okay, the result will be 9, and in which 2 is present at 0th index and 7 is present at 1 index. So instead of returning 1, instead of returning true, here we have to return the indexes. Okay, so let's first create the hash map. So hash map integer, the value will be integer value and keep pair, right? So the name of the hash map will be hmap equals to new hash map. Now let's populate the hash map. So for int, so let's use the enhance for loop. So nums. Okay, so here hmap dot put num comma hmap. Here we have a function get or default. If the num is present in the hash map, it will increment the frequency or it will store 1. So num comma 0 plus 1. So using this we can populate the hash map. Now here we want the two variables difference, that will be initially 0, and the I. Okay, now for int I equals to 0, I is less than nums dot length I plus plus, and here we will first calculate the difference. So difference will be target minus nums of I. So here we will first check whether the difference is equals to nums of I, right? We have seen that, and if the difference is equals to nums of I, then we have to check the frequency, right? So hash map dot get difference, right? Here we have to check whether it should be greater than 1. If it is, then we will break. Okay, why? Because let's say the array is 2, 7, 11 and 15, right? And the target is here 9. Target minus 2, the difference is turning out to be 7. So we are actually checking whether this 7 is present in the hash map or not. And yes, it is present, right? But here the value of I is pointing at to 0. So we found our pair 2 and 7 in which I is pointing at 0, but we don't know where this 7 is going to present. So we have to have the another for loop in which we want to check in which index this 7 is present. Okay, so due to that we will break it from the loop. But if the difference is not equals to nums of I, okay, at that time also we have to do something. So if the difference is not equals to nums of I and hashmap dot get, sorry, dot contains key. Here we are going to check whether the hashmap contains the difference or not. If this is the case, then also we will break it, and that's it. Now we are going to have the another for loop. Int j will be from 0 nums dot length j plus plus. Now here we are going to check if, first of all, I shouldn't be equals to j, right? And nums of j is equals to val. If this is the case, then we will return the array, because they want us to return the array, right? So in that array, two values will be present. So new int I comma j. And if this is not the case, that we didn't found any pair, at that time we have to return the empty array. So return new int, that's it, that too of size 2. Okay, so I hope this should work. Let's run. Okay, so this should be the difference. Okay, you can see that while running the code, 3 test cases are passing. Let's submit it. Okay, so here we have passed all the test cases, so this code is actually working. Okay, so that's it. In this way you can solve this problem. So thanks for watching till here, and don't forget to like, share and subscribe to my channel. Okay, thank you.